Okay, so hello again and welcome. I'm here now with Michael McCreary, and he is going to be taking you through the first in the database series. He's going to be teaching you how to connect to, set up and use a local database. So I know lots of people were really keen to learn about databases, so we've tried to create a lot of content around that for you. Michael is certainly our database guru around here, so I'm sure he is looking forward to showing you what he's got. Over to you then, Michael.
Thanks very much, Heather. Okay, good afternoon. Certainly afternoon then. Typical Edinburgh summer's day out the window at the moment. See a lot of white black clouds. So, well, I hope it's a little nicer wherever you are. And as Heather mentioned, today's talk is going to be going through creating a local database app. In particular, it's going to be a very simple notes or sort of memo app. A few people are mentioning getting an echo. Is that happening for you, Heather?
I am not hearing an echo. Let me just try.
No, apparently it's gone now. It must have just been a brief issue. Okay, I shall continue. Yeah, as I mentioned, I'm going to create a very simple notes and memo app sort of that allows you to kind of, it's not the most exciting app, but hopefully it'll go through the basic techniques that are required to create a simple database app in LiveCode. So let's get started. So I guess the first question is, what is a database? Well, yes, simply put, a database is a structured collection of data. So maybe a simple text file that contains a comma-separated list of names and addresses, that could be thought of as a database. Maybe an XML file that contains a list of countries and maybe their iOS codes, that's a database. Essentially, a database is anything that's a kind of structured collection of information. Lots of different types of databases, but in this talk, we're going to focus purely on relational databases. So a relational database is defined by a set of tables. So in the example of our contact list, our table would have a column maybe for first name, last name, email address, telephone number, whatever kind of information you wanted to include in your contacts. This collection or set of tables is known as our database schema. Next part of our database is the actual contents. These are the rows of the tables. So for example, in our contact example, you would have a row for each contact in your address book, and each row would have a filling out for the first name, the last name, telephone number, as you'd expect. Next, we need to have a means to query the database. That is, insert data into the database, extract data out of it, update it, search for particular records, things like that. So that's done most commonly by a query language. Now, in the examples that we're going to consider, we're going to be thinking about SQL, which stands for Structured Query Language, or sometimes pronounced as SQL. That's just a common language between several database types that allows you to extract information and insert information into your database. The final part of your relational database is the actual database engine itself. Now, the database engine, that's merely how, or rather more than merely, that's how the information in the database is actually stored. Now, there's lots of different types of databases, and each uses their own database engine to store the information in a particular way. So let's consider a few types of SQL databases. Now, you've probably heard of MySQL, you've certainly heard it mentioned around. Now, MySQL is one of the most common types of SQL database, and it is run on a server which has special MySQL software running. Now, I've mentioned also up there PostgreSQL and Oracle. They're very similar. They run on a server and have special software running on that server. Now, it's quite a lot of effort to kind of configure these servers, quite cumbersome, but what they do give you is a lot of power. So if maybe you think about a web store that's processing thousands and thousands of orders at a time with a massive database behind it, That's the kind of example where you'll be using a server-based database. It's got a lot of information to process, and it needs to process that information at very high speeds to many, many users across the globe. That's the kind of thing where a server-based database is best used. Another type of database is SQLite, which uses the same SQL language to access a database as MySQL, Postgres, and Oracle, but it's much more lightweight and exists locally. So an example of where you might want to use an SQLite database is, for example, a single user app. So the example that we're going to go through today, which is a notes app, that's a prime example of where an SQLite database is very good. It only serves a small set of data for a single user, so rather than being open to the whole wide world, it's open to just a single user from a single app. SQLite databases are fairly lightweight. The information is stored in a file locally. It doesn't require any extra software to be installed on the local machine, but it only gives access to a single user and isn't best for serving masses of data. So let's begin with our database. So as I mentioned, we'll be creating a simple notes database. Now, it's maybe not the most exciting, but it should hopefully give you an example of how best to access and create databases in LiveCode. So the first thing we need to do is create our tables. And the simple table that we're going to start with is our notes table, as you'd expect. So this is the SQL syntax for creating a notes table. So it says, if you can see, create table notes. The first column in the notes table is an identifier. Now, the identifier uniquely identifies each entry within that table. So the first entry you can notice that the ID is an integer. So the first entry will be entry number 1, the second entry will be entry number 2, entry number 3, entry number 4. So each entry has a unique identifier. So that allows you to have several different notes that might have the same title and body you notice below, but their identifier will be unique to them. That way we can access those entries uniquely without having any confusion as to one entry over the other. So for example, you could think of a contacts database, which you might have two people with very similar or the same names, but they have two different records. They'll have a unique identifier that will mean they can be separated out. So you know it's also got a title and a body. So next to them you can see text as the type. So pretty much all types in SQLite are the same. They're all essentially stored in the same way, but there is kind of a superficial layer on top which allows you to differentiate between numeric types, text types, and date types. So you'll notice the created date and the edited date, they're stored as date times. So that means that they're kind of stored within the database uniquely as date times. As I've said, they're actually essentially the same under the hood, but they kind of provide a superficial level on top which allows you to know that the created date is a date time, the edited date is a date time, whereas the title and the body, those are just pure text, and the ID is an integer. Now the final part you'll probably notice next to the ID is its primary key auto increment. So basically that means the primary key, as I mentioned, is that allows you to uniquely identify the given row, and the auto increment means each new row that's entered will automatically be given a new ID that's one more than the previous. Now there are a few ways to store IDs. We're using the integer auto increment method. Another option is to generate a unique ID for each one using some kind of unique UUID generation tool, which is also equally valid in some ways, is actually better because it has fewer security holes. But for our example, in a single user app, using an auto-incremented integer is the simplest way. So that's our database schema in SQL. But how do we actually go about getting our database into LiveCode? Well, we use RevDB. Now, RevDB is an external, it's a set of functions that are developed for LiveCode that allow you to access SQL databases. Now, for SQLite, as I mentioned, it's a simple file that represents a database. So the first thing we need to do is choose where we want to store our database on disk. Now this depends probably on the platform and how you're developing. So for example, on mobile, there's a special location for it, whereas on desktop apps, you might want to put it in a place where you can actually access it for testing, and then when you're doing it in the live standalone environment, you may want to put it somewhere different so the user doesn't know where it is, sort of in the preferences location, for example. So once you've chose your location to the database, you need to open a connection to your database, which will give you a unique ID. That unique ID can then be used to access that database for all future connections. So once you've opened the connection, you'll need to do that once. It will give you a handle to that database, and then you can perform all your future database actions using that ID. So how do we actually get that ID? Well, we use RevDB, and in particular the command, or the function rather, RevOpenDatabase. The first parameter you pass is the type of the database. Now, as I mentioned previously, there's several types of database, all of which RevOpenDatabase or RevDB gives you access to. But today we're only concerning ourselves with SQLite. So the first parameter is SQLite, and the second parameter is where that database exists. So that's the path on disk to the database. Now, conveniently, if the database doesn't already exist, RevOpenDatabase will create that database for you. So it doesn't matter if that file doesn't actually exist, it will be created by RevOpenDatabase. And then, once we've got our connection to the database, we use RevXQ SQL to execute our previous create table notes, so on, which will create our database table, our first database table. So if I go back to what we had previously, create table notes, that's a block of SQL that we want to execute. We will execute that with RevXQ SQL. So you notice RevXQ SQL is a command. The first parameter is the connection ID that you got from RevOpenDatabase from the previous slide there. And the second is SQL you want to execute, and in this example, it's our create table notes. So what I'll do is I'll show that in the example in the context of a live code stack.
While you're getting that up, Michael, there were a couple of questions coming in the chat. So somebody asked, what were your thoughts on using SQL versus FileMaker Pro? Don't know if you have any comments on that.
They're two quite different things. FileMaker Pro, now I've not had a massive experience with it, but FileMaker's a sort of entirely separate thing to LiveCode and does provide a database backend, but also provides sort of a quite restrictive front end. So if you want to do what FileMaker lets you do, then it's actually very powerful, and it's very good for creating database apps. What sort of building a database app in LiveCode and using SQL directly gives you a lot more power. You have a lot more freedom to do anything you want. It's a bit trickier, it's a bit more involved, but from that you can essentially create any database app you want. As I say, I've not had a massive amount of experience with FileMaker, so I can't say for sure what the pros and cons of it are, but I can say that when you're creating a database app with LiveCode and using SQL as the back end, you can pretty much do anything you want. You've got direct access to the database, and you've got direct access to the user interface through LiveCode, so you can essentially create any app that you so desire.
That's very cool. Somebody also asked early on, will there be access to the slides and the code that you're using for this course? Will this be sent to the attendees?
Certainly, yeah. That can be done.
We'll make that a bit available to you. And somebody asked, Albert Magira asked, can you use Firebase with LiveCode? And somebody else has already asked him to say you would use a web service or an REST API to do that, which I believe you're demonstrating later in the series.
Yes, the future parts will expand upon database access, and we'll show you how to connect to a database in the cloud. But for the moment, we're concentrating purely on local databases. Great. So with that in mind, let's look at our code for connecting to our database. Now you notice that I'm doing it in pre-OpenStack. Now that makes sense. As soon as your stack is launched, you probably want to open a connection to the database. And the first thing we do here, local tdb path, that is a variable which we want to put into our path to our database. So as I mentioned, that's just a file.
Sorry, interrupt you again a second. Somebody's saying that the code font is a bit small to read. Can you possibly make this any bigger?
Let's see.
Zoom in a bit.
Is that better?
Looks better to me. What do you think, Arthur? Is that better? Waiting. Anyway, I think, yeah, that looks a lot better.
All right. So this is the first thing I mentioned that we need to do is decide where we want to store our database. So you notice I've switched on the environment, and I'm choosing the path based on the environment. So on mobile, we use special folder path documents. Now, special folder path documents is a folder that gives you access to read and write. So basically, it means you can store something there and edit it. So that's the best place to store it in mobile. Development, that's the IDE. So what I'm doing here is I'm putting it next to the current stack. And that's useful because it means you can see the database file there. You can delete it. You can view it in a different product if you want to view the contents of a database, which is very useful. And I'll show you that in a second. So that's just for kind of debugging. But when you're actually running a standalone, a desktop standalone, what I do is I place it in special folder path preferences, and then I create a subfolder called notes. You can see that here, just to keep it away from everything else. You can put the database wherever you want, really, but on mobile you are restricted to certain locations where you can write to. So, and I called the database itself notes.db. Now, this little line here checks to see if the database already exists. Now, if the database doesn't exist, we want to pre-populate it with our tables. If it does exist, then we don't want to execute the create table syntax again. So that kind of makes sure that we only create the tables once. The first time the app is run. The second time the app is run, the tables will already have been created, so we don't want to do that again. So here's the line we saw earlier: rev open database, SQLite, and the database to the path to our database. And I check the result from the function and make sure it's an integer. That being the connection ID. If it's not an integer, something's gone wrong. And if we've got a connection ID, I put it in a local variable here, or a script local variable, SDB connection ID. That means all future database database access handlers can get access to that connection. And then I go about calling RevXQ SQL using our database connection ID and using our database schema. Now what I've done here is I've put the database schema in a custom property of the stack. Now you can put it maybe in a text file or possibly directly within as a constant within. It's probably easiest to put it into some kind of file or custom property because it just makes accessing it a bit easier. So I'll show you that here. Got a custom property named database schema, and that's got create table notes and our syntax there. So that saves us having to type out or having to store the SQL directly within the script. And you'll notice here on close stack, I use rev close database and use that same local variable, which is our global connection ID, SDB connection ID, to close the database connection once you're done. Now, you don't really need to do that because it will automatically be closed when your app is removed from memory, but it's just a nice little bit of sort of tying things together and shows you how we can use the same connection ID across different handlers. Now, that's executed in pre-open stack, so it's actually already happened when the stack was launched. And you'll notice here, this is a folder here, it's got we've got notes.db next to our current stack, so that's because we're running in the development environment. That is the IDE, so it's decided to place it next to our current stack. Now what I've got here is a little tool called SQLite Manager, which is it's an add-on for Firefox. There's many other similar tools out there. This is one that I just happened to find, and what that does is lets you view and browse the contents of a database. So your database, I can look at our notes.db and it will show our notes table there. It will show the values in there that we used to create it with. And if we browse it, it will show that there's nothing actually stored within that table. So it shows that our database has successfully been created, but we've not put anything in it. So that brings us on to our next step. which is inserting into our database. So once we've got our database created, we now need to populate it with some notes, some records. And this SQL for doing that is fairly simple. Insert into notes, title, body, created date, edit date. So that's the values that we're going to want to, or the rows that we're going, the columns rather, that we're going to want to insert into. So we're going to insert title, body, created date, edited date. Notice that we don't insert an ID here because we set the ID to be auto increment that will automatically be assigned when we do the insert. So the very first row that we insert will be ID 1, the second will be ID 2, the third will be ID 3, and so on and so forth. So, and these are the values we want to insert afterwards, note title, note body, that makes sense. But the next two are date time now, which are a little confusing also. I'm missing a closing bracket there at the very end, but ignoring that, date time now, and what that does is that tells us we want to use for the date the current time, the current date time now. I'm just reading out what's there, but that it kind of makes sense. You want to use the current date for the created date and the current date for the edited date. And these little SQLite functions allow you to do this without you having to get the date yourself. It's kind of a nice little neat handler, and that's kind of one of the advantages of setting the type. Remember when we went back to our setting it to date time, that means that it understands that the date time functions will be used.
Matthias is asking, is there a comma missing in your code?
Yes, there is. There is a comma and a closing bracket missing between note body and date time now, and a closing bracket at the very end. I really should have went over that, but he is correct, well spotted. So let's actually go back to our stack and show that in practice. So if we go to inserting,
It seems like a good time to ask another couple of questions that have come in the chat. Somebody asked a question earlier on, which I thought was interesting. I can find it. Basically asked, why not use a LiveCode file for a simple single-user database?
That's a very good question.
Yeah, I said that here. It was Jonathan asked this. For a single user, why not just store data in an LC file? Does a database retrieve data faster? So
that's a very good question. And in many cases, possibly a simple file might be sufficient for your needs. If it is a very small and very simple set of data that you're working on, a simple text file might be sufficient. But anything more than essentially a list of data, a text file becomes somewhat cumbersome. You can't access it with the speed that you want. If there's lots of entries in the text file, finding, say you've got 50,000, finding the 10,000th record in that text file will become very slow. You'll need to parse it line by line. Searching it can also be very slow. And the most interesting thing, and we'll come onto that a little bit later, is you can do what are known in SQL as joins. That is sort of linking different bits of data up together. So for example, in our contact list, you might be able to have a list of contacts and then a list of messages that they have sent you. But the message list links back to a contact, which might be maybe two separate text files. You've got a list of contacts and a list of messages. Joining those two up so that who sent the message can be looked up in the list of contacts. That can be very slow in text files, but in databases, they're designed for that kind of thing. So essentially, I've gone a long way around to saying that text files are good for simple sets of data, but once you're operating on large sets and trying to do slightly more complicated operations, they become somewhat slow. So let us look at our new database. So we've got a different one, inserting here. Oops, easy. That. Oops. For some reason, we don't appear to have a database, so let's have a little look and see. No, local. Excuse me for 1 second, I'm trying to figure out why our database has not been created. I don't understand why, so what I will do is restart. It's a little confusing because it's exactly the same stack as the one we used previously. Okay, so let us ignore that briefly and move on to the syntax directly for creating the database. Inserting the database. So you'll notice here, if I make this wider here, we have create note, which is a little handler here, pass the title and the body. What we do is insert into notes, title, body, create date, edited date, and we pass in the title, the body, and as we had before, date time now, entity query. Like we did with creating the tables, we call RevXQ SQL using the connection ID and passing the query that we want to run. And again, check to see if it results in an integer. An integer, usually in this case, it will return 0, will suggest that it's been successful. If it's not an integer, it will be an error message, which will tell us that something has gone wrong. The next thing, moving on from inserting there, is creating a note as UTF-8. Now, it's important to note that LiveCode encodes text in different ways. So if somebody has typed in some interesting characters, some multi-byte characters into the fields for title and body, they will be encoded in a particular way. So what you want to do is make sure that they're encoded as UTF-8 before you insert them into the database. So what you call is text encode UTF-8, telling them to encode from the current encoding of the p title into UTF-8 and then store that in p title. Now you notice this line here, pragma encoding equals UTF-8. What this is doing is telling SQLite to expect all operations to be using UTF-8 encoded text. You'll need to execute this once, and it should probably be done at the very beginning, probably as soon as you open the database connection. So it's exactly the same as before, but this time p title and p body are UTF-8 encoded, which means that any fancy characters that are in the title and the body of the note will be encoded properly in the database and they'll be handled correctly. And finally, what we do is use placeholders. Now this is an interesting one. And is there to guard against something called SQL injection. Now, what if somebody enters my note apostrophe semicolon delete from notes? Now, what you might see is happening there is if we were doing the previous method where we were just inserting the direct p title and p body into our query, the quotation mark will close the previous quotation mark that was signifying that the title was about to be seen, and then all of a sudden the query, the user has direct access to the query. So rather than being within the quotation marks that were kind of surrounding p title, they've escaped from those quotation marks. The semicolon there, that tells SQLite that the previous query is finished, and now they can execute whatever they want. So in this case, delete from notes, that will delete all the contents. And now you can imagine this can be quite a serious security hole. For example, in a web-based database where somebody could enter delete from notes or delete database, and essentially they have full access to the database and can clear everything out, the entire contents of the database. Now, in a single user database, it would be a pretty stupid person that did that, because they would delete their own database, but it's pretty important to guard against. And the best way to do that is to use placeholders. Now, this is an example of it here, exactly the same way, RevXQ SQL, but this time instead of putting p title and p body directly into the query, we use :1 and :2. Those are known as placeholders, and that means that the SQLite driver will replace :1 with p title and :2 with p body. And what it will do is it will appropriately escape any nasty characters. In this case, the apostrophe there will be escaped with a \apostrophe, and that means that it will be ignored in or will be treated as an apostrophe rather than a closing apostrophe, and everything will happen as you would hope for. So it's pretty important to be aware of that, and it's a pretty big security hole if your app doesn't take care of SQL injection and using placeholders. But fortunately, it's really easy to do, and actually, in many ways, it's cleaner than inserting p title and p body directly into the query. So you can see it here: :1, :2, and then we say those are p title and p body. So that's how we create the note using placeholders. So let's close that down. Let's see if part.
This looks like another good question opportunity.
Sure. Yep.
So Tom asked, one moment, why do Michael's commands end with return empty? I thought a return value was only needed for a function.
Oh yeah, that's actually a very good question. Let me go to the scripts. No, that's the property inspector. So yeah, so my command on here I'm using on, but command is the same: return empty and return key error. Ignoring the syntax above here, just done something a little different here. The idea here is that you can actually return a function from a command, and it will be present in the result. So, for example, ignoring everything else, libdb insert is a command, and I can get the result by doing if the result is, or using the result and not empty, etc. So the reason I do that is I use functions primarily when you actually want to return a value. There's something specific that you want to return. For example, get me the current time of day, get me the number of entries in the notes table. Whereas create note doesn't actually return anything as such. All it does is performs an action. But what's quite useful is if an error has occurred, I can return that error. So you can check the result to see if there's an error string. If there's no error string, i.e. empty has been returned, you can ignore it and everything's worked as expected. But if an error string is returned, then something's gone wrong, and you can handle it appropriately using if the result is not empty. That's an example there. That's just a particular way that I like to code things. You might want to do something, you might want to do yours a little bit differently, but that's something that I find is quite nice, and it's quite a good way to handle errors and sort of using the return statement. Okay, so One thing that we might want to do is build up a library of sort of common database tasks. Now, as you sort of go through and develop database applications, you'll notice that you'll do quite a lot of common things. You'll do quite a lot of inserts, you'll do quite a lot of updates you do a lot of queries and such, and you'll notice you'll probably reuse a lot of the same code or replicate a lot of the same code within your stack. So it'd be quite nice to sort of put a lot of common tasks into a simple library that can sort of speed up our development. And one thing that might be really nice to do is, instead of sort of passing or building up that full insert into SQL syntax, could we possibly just pass the name of the table we want to insert an array of values? So for example, if we go back to our little create note handler here, tdata is an array, put the title into tdata title, put the body into tdata body, the date time now for created date and edited date. Could we just pass those up instead of building a full, or could we build a handler which took those and created the insert command instead of building a full insert into SQL command? And as it turns out, yes, you can. It's not too difficult to do, and I'll take you through it. So if we go here, basically all this command libdb insert does is builds up the insert command appropriately. So it goes through all the data in pdata, repeat for each key in pdata, and it creates the insert command using placeholders. libdb format value formats it appropriately. So basically after that, you've got your insert command built, and then it calls libdb execute, which is basically a wrapper around RevXQ SQL. So essentially it builds your insert command and it executes it. So let's have an example of that. So if I scroll down here, we've passed through the table that we want to insert into, which is notes, and the data that we want to insert, which is note body, note title, date time now, date time now. And as we execute it, we'll notice that our query now is insert into, and so on and so forth, and it's got the appropriate placeholders in place for body, title, and it's got the date time now for created date and edited date. Now, one thing you've probably noticed is I've put star F before created date and edited date. That's what that does, is tell us that those are functions and they shouldn't be replaced by placeholders, because they won't work correctly if they're replaced by placeholders, because they'll be escaped. So you notice the quotation, the apostrophe marks there will be escaped if they were replaced by placeholders. Basically then it's got query params, which is what we had before, placeholders. Now notice you can, before we passed them as separate parameters to RevXQ SQL, the first one was the body, the second one was the title. You can also pass an array with elements. So array element number 1, that corresponds to placeholder number 1, and array element number 2 corresponds to placeholder number 2. So now that should have inserted a note into our database. If we bring up our little database browser tool and refresh it, you can see that we've got note title, note body. We can do the same again. New note. So and we go back to our browsing tool, refresh, and we've got our new note there. So this little tool in Firefox is just allowing us to view the database temporarily until we get to something a little more advanced within our app, that is. So that's a really nice way to insert into the database without having to sort of build the query yourself. The next thing is extracting information from the database. So the way we want to do that, or the way we do that, is using the SelectStar from notes. So it's the select syntax in SQL allows you to extract the contents of a table. So in this case, it's our notes table. Star, that's just a wildcard character. That means give us everything from the contents of the notes table. And there's two ways you can get information back from RevDB. You can use Rev Data from Query, which will fetch it as a text, and Rev Query Database, and that will allow you to get access to the individual values directly. So I'll show you the differences between those two and where you might want to use one method over the other.
So I have another question for you here. Yep. Tom is asking, how would you store a note containing formatted text?
Formatted text, a good way to do that would be to use either sort of HTML or RTF. So you can get the HTML text of a field and the RTF text of a field, and you can store that directly in the database. And then once you're putting it back into the field, you can set the RTF text of the field or set the HTML text of the field. That's the simplest way to do it, I think. So let's see. So this database is populated with a whole bunch of notes that I had when I was testing, and we'll look at what the fetch text as note does. So this is our query, SelectStar from notes, and we use Rev Data from query, comma, and return. So that basically says the fields will be separated by comma and return. So I think a good example of that is 1, that's ID, comma, note title, comma, note body, comma, created date, comma, edited date, return, 2, so on and so forth. And we use Rev Data from query, and that returns this as a blob of text. And then we decode it, because all the text was inserted as UTF-8, we decode it back into Unicode text, which LiveCode can understand, and then we can put it into the field there. So this is an example of pulling out the information from the database. Now you can probably see an immediate problem is that some of our notes have return characters directly in them. So there's no real way to differentiate the end of the note, this note here, and the sort of return character in the note body. So if you're parsing it line by line, you wouldn't really know which was which. So really, it's not fetching it as text like that is not great. Another example might be somebody puts a comma within the note title, the note body. You don't really know how that works. Of course, you can use different delimiters, you can use different characters, but the same problem still occurs. For example, if you use tab and equals or something like that, the same problems will still happen if somebody enters tab or somebody enters the equals character. You won't really be able to differentiate them from the delimiters. Now, fetching it as text is a good way to sort of fetch an individual entry or something that you've got a bit more control as, but a much better way is to use the Rev Data from query. So this is an example here of using a data grid and fetching the contents of the note using Rev Data from query. So I'll show you how we do that. So the query itself, Rev Query Database, not Rev Data from query, sorry. SelectStar from notes, the query itself is exactly the same, but Rev Query Database, that gives us what is known as a cursor. So make sure that the cursor is an integer. So the cursor basically is a handle to the information returned from that query, and we can then use that cursor to extract that information. So you notice I've called this handler, or this function rather, fetch notes as array. So what we're going to do is, rather than return it as a blob of text, we're going to return it as an array with each note stored as an element within the array. So first element in the array, tcount number 1, and repeat until the cursor, the query is at end. So this basically says repeat until we've got no more information in this particular query. So we've got every column or every row from it. Fetch the column names, so that fetches all the column names within the cursor. And then for each column in there, so the column names are title, body, created date, edit date. For each column within the cursor, extract that column. So Rev Database column named, get the Rev Database column name, tcursor, tname, put it into tcolumn value, and make sure we appropriately decode it before we store it into our data array, ready for returning back. Then we call Rev move to next record, which will move to the next row in the column and make sure we add 1 to our count. So I'll show you what that gives us at the end. So TData now has 6 individual entries. Entry number 1, note body, the ID number 1, created date, edited date, title. Number 2, exactly the same, the body for the note, the title for the note, the edited date, the created date, the ID. So that's a much more usable format that we can then pass back to our interface and process it appropriately. One really nice way that we can do that is if you've ever used data grids, which this is an example of, it's really trivial to populate a data grid. In fact, that's exactly the data that the data grid expects. So we can set the DG data of our little data grid here. All I did was pre-pop, tell it that it's got those 4 columns there, set it as fetch notes as array, and we can get the full contents of the data in our database there. So just show a brand new test note. Create that note. See that now here. Our brand new test note has been fetched from it, and you can see the date that was being created and edited was 15:46, which was only got 15 minutes left, or less than that, 5. So the next thing we probably want to do is consider updating. Now, updating is pretty similar to inserting. Update notes, set the title to equal new title, the body to equal new body, where the ID is, and that's the ID of the note. So again, you can see it's pretty similar, and you can probably see that, like we did with the insert command, rather than building up the query yourself, a really nice way would be to pass an array into the to the command to update any notes, and build up the SQL command from that array. That's a much quicker and nicer way to do things, rather than doing it directly. So you'll notice here, I've added a little edit button, so we can go here and edit it. And then if we go back, you should see newly edited note. And if we look at that in our script, like before, put the title into tdata title, body, and update the edited date, call libdb update. So we've moved this into our database library, and this does exactly the same as our insert command. It repeats through each data in the data array, formats it appropriately, builds up the query, and calls RevDB execute, which libdb execute is just a simple wrapper around. So we're slowly building up our database library. We've got libdb insert. We've also got a command to fetch data as that's libdb execute. Fetch data as text, which calls rev data from query, which we saw before, and fetch data as array, which is exactly the same command that we had before when we fetched the data as an array. I've just copied this into libdb. So this is now a nice little database library which we've been building up, and I didn't cover before, but what you can do is start using stack right at the very beginning. We've got libdb then in the message path at the very end, and we're ready to call the functions there as we go. Now we're pretty much at the end of the time we have right now, but we've got 2 more sessions, so we can continue on where we left off, where I'll show you how to move our simple database up into the cloud, as well as covering a little bit more in how you might want to have a slightly more complicated database with extra tables. Well, I'll cover adding categories and joins. But what I can do is go through any questions briefly, very briefly, before we move on to Kevin's keynote, which is coming up next.
Absolutely, Michael. That's really interesting. I enjoyed that. What I'm saying is people can go into the Slack channel that we've set up for the conference, and if you pop in there as well, then they can ask their questions in there. So you can take any questions that weren't covered here. I think the only major one here that might want a quick answer was, where are we? Jonathan asked, are some characters like low-level ASCII forbidden for a DB? Will they confuse the database? I've had to base 64 encode some data. Is there a better way? Did you get? Oh. Oh, I'm not sure what happened there. Are we still here?
Placeholders will get around that issue. It will escape any characters using the appropriate method for the given database type. So the escape characters are different for each database type. SQLite has a certain set of escape sequences. MySQL has another set, and Postgres as well. They all do it. They're pretty similar, but they all escape different characters slightly differently. So you have to be aware of that. And the best way to do that is to use placeholders, as we discussed before when talking about SQL injection. And that will escape any particular nasty ASCII characters appropriately. You've got another thing to be aware of is dealing with binary data, which is a little bit different. And I'll actually cover that in another talk next time, which will explain how best to do that as well.
Fabulous. Okay, thanks very much, Michael. As you mentioned, we do need to stop now so that we can start the keynote on time. So guys, I'm going to close the session, then I will be reopening for the keynote. So please all check your email for the latest link to the 5 p.m. session where you can rejoin and watch Kevin Miller giving his very exciting and interesting keynote. I'm looking forward to it. Okay.